Good morning, this is Mr. Gagnon, and we're going to take a peek at problems 1 through 9 on Newton's second law. This is just to give you an idea of how to solve some of these Newton's second law problems. At first, they're very, what I would say, simple problems because you're looking at just two variables, and then you have to solve for the third. So let's just take a peek at number 6, and we'll also take a peek at number 8. Okay, so number 6 says that we have a 95 Newton net force. It's applied to an ice block with a mass of 24 kilograms. It says find the acceleration of the block if it moves on a smooth horizontal surface. So we're considering that the force of friction is 0 because it says a smooth horizontal surface. Now in real life that really doesn't exist, but that's all they give us. So using Newton's second law, force is mass times acceleration, we need to solve for acceleration. So this is one of the easier types of problems in that all we have to do is just rearrange the formula to solve for A. So rearranging the formula to solve for A, we have A equals net force over mass. Okay, and A equals 95 newtons over 24 kilograms. Okay, and then you just solve for that. So get the calculator out. 95 divided by 24. So the acceleration of this object without friction would be 3.96 meters per second squared. Okay, so that's number 6. That's the most simple type of problem we're going to be looking at. You have 3 variables, you're solving for 1. All right, and let's take a look at number 8. Okay, so we got a little bit more information here. So it says the average net force is what they're looking for of a truck. The mass of 8,500 kilograms. It says it does it in 10 seconds. And it's initially traveling, I know that that's the initial velocity, of 20 meters per second. So from this question, you have to think that the truck is going from 20 meters per second to a stop. So because it's going to a stop, the final velocity is 0 meters per second. So also I'm looking for force, just like in number 6. And we know that the net force is the mass times acceleration. Okay, so now here's where you have to get into the art of substitution because we don't have acceleration. But if I substitute final velocity, initial velocity, and time for acceleration, I can come up with a solution. So it'll be mass. So acceleration is equivalent to the final velocity minus the initial velocity over time. Okay, so all I did was I substituted this formula for my kinematics equations to replace acceleration, and now I can solve. But I can even simplify it even more because my final velocity is 0. So here we go. Mass okay, so we've got mass times the negative of the initial velocity over time, 8,500 kilograms multiplied by 20 meters per second, a negative of 20 meters per second, all over a time of 10 seconds. So 8,500 times 20 divided by 10. Okay, the force required to stop that thing is negative 17,000 newtons, okay, or negative 17,000 apples, as we've been saying in class. So that is how to get the force given when you're not really given an acceleration. Okay, hope that helps. This is for problems 1 through 9 in the classwork, and also through the homework, it's through problems 10 through 19. So problems 1 through 9, and then 10 through 19.